Okay, so we need to now kind of connect some dots between the nervous system, central nervous system especially, and another system, the last system of the body that we really need to understand, and that's the endocrine system that's coming up in just a second. But first, a quick refresher on neurotransmitters, this very important part of the central nervous system, right? These are the chemical messengers of the brain and the spine. So I found this one kind of quick reference. Feel free to pause this and check your notes. Make sure you got a good jelly for all these. This is a very kind of brief refresher on some of the basics. And we've gone over most of these, if maybe not one of them, but so quickly, we've talked about adrenaline made up of epinephrine and norepinephrine, right? That stimulate the body. Well, here, technically, they're calling adrenaline, or they're referring to adrenaline, which is epinephrine, and noradrenaline, norepinephrine. So as you can see, as we've seen a million times, different names for the same daggone thing because psychologists are big fat jerks. Anyway, adrenaline, epinephrine gives us that shot, that jump start of excitement, as we've learned. Norepinephrine keeps the stimulation going. So one of the effects we haven't mentioned of norepinephrine, it can help for long-term concentration. Aside from everything else we've said about it, we've mentioned dopamine is the woohoo pleasure chemical found especially, but not only, in the nucleus accumbens. That was a part of the brain we mentioned before. Part of the basal ganglia is the nucleus accumbens, and that's part of the reward system of our brain. When neurons in the nucleus accumbens, it's deep in the core of our brain, when those neurons spit out dopamine, it makes us feel amazing, we feel rewarded, and we want to repeat whatever we just did. That's dopamine, at least in the nucleus accumbens. Now, this doesn't tell you on this chart, but remember, in this quick review, dopamine in other parts of the basal ganglia also helps control some of our movements, because dopamine, aside from being a pleasure chemical, is also the culprit of Parkinson's disease. When a person suffers from Parkinson's disease, they tend to have terrible tremors, and they lose control of their motor functions in a lot of ways, and that's because they lose neurons containing dopamine in other parts of the basal ganglia, having nothing to do with pleasure. Okay, serotonin we mentioned is implicated in depression. It's believed that people who are depressed don't have enough serotonin, which is why antidepressants nowadays block the reuptake of serotonin, trying to keep serotonin in the synaptic space, filling up receptor sites. We've been all over that. Serotonin also is part of our sleep and wake cycles. Like serotonin is low in the middle of the night and higher throughout the daytime. I've seen some suggestions in research that this is why if you wake up in the middle of the night, maybe you're in a bad mood, or if you read a text message because you hear your phone vibrate and you wake up and it's 3 a.m. and you read a text message, you might have a strong, sad response that you wouldn't have if you read that same text message at 10:30 a.m. Anyway, mood and sleep regulation. Serotonin's a very complicated neurotransmitter. We know that GABA is a major inhibitory neurotransmitter. No surprise, since it's inhibitory, it stops neurons from firing. It is a major part of the parasympathetic nervous system, calming the body down. That's the opposite of, let's jump over to glutamate. Glutamate is an excitatory neurotransmitter, and one of the things it does, it's involved in memory formations from a biological sense. When we're thinking hard and trying to make memories, we're probably using a lot of norepinephrine because we're focusing, we're concentrating on something, and glutamate is going to surge to try to make lasting memories for us. But another memory neurotransmitter is actually this one, folks. It's called acetylcholine. hard to say. It's a weird spelling, maybe, but acetylcholine, this says is a learning neurotransmitter. Sure, yes. It's also implicated in memories. Okay, making memories, memory formation. Obviously, making memories is an important part of learning. And acetylcholine is also one of those neurotransmitters that's involved in learning and memory making. And here's something to keep in mind, maybe a little mnemonic as well. Guess what neurotransmitter, take a wild guess, what neurotransmitter starts to diminish or does deplete when a person suffers from Alzheimer's disorder, Alzheimer's disease? Mnemonic, Alzheimer's disease. Alzheimer's is a big, long, weird name that starts with an A, just like acetylcholine, a big, long, weird word that starts with an A. Acetylcholine is diminished in Alzheimer's patients. Alzheimer's patients have this protein, this plaque that attacks neurons in certain parts of the brain. It tends to start in the hippocampus, where neurons are attacked by this plaque, and those neurons are withered away. They're degenerated, they're killed off. And those neurons that die off or don't do their job properly, those neurons contain acetylcholine. So without the acetylcholine, we have the memory disturbances of Alzheimer's disease. Something important to mention. They do sometimes ask about acetylcholine in these FRQs. So make sure we've got the basic functions down, folks. Find your jelly for each of these major neurotransmitters. We also know endorphins. This says it's the euphoria neurotransmitter, makes us feel wonderful. Sure, but let's specify there. Endorphins inhibit pain. They take pain away. And yeah, that makes us feel good when pain goes away. But I don't want you to confuse endorphins with dopamine. Dopamine makes us feel euphoric and amazing and satisfied and wonderful. Endorphins take away pain. Okay? Now with that, as a quick review of neurotransmitters, I need to introduce you to another kind of chemical called the hormone. Now, a weird thing is that endorphins are neurotransmitters, but endorphins are also hormones. Norepinephrine is a neurotransmitter, but it's also a hormone. Let's make sense of what we mean by that. See, a hormone and a neurotransmitter, they have something in common. A hormone and a neurotransmitter are both chemical messages. They carry a message. Like acetylcholine carries the message of, hey, let's try to remember this. Fire, neurons, fire. We want to make this memory, fire. Carry the message of excite, make something happen with neurons. Where GABA carries the message of, whoa, stop firing neurons, quit it, go back to resting potential. We need to calm down, parasympathetic activity, carrying messages. Well, hormones carry messages too. Hormones can also land in neurons' receptor sites. So neurons and hormones can be very similar in those ways, but they also have some major differences, such as hormones come from glands, not neurons. Neurotransmitters come from neurons. So neurotransmitters are chemicals that, right? They do their job from one neuron's axon to another neuron's dendrite, bam, really quickly, neurotransmitters have their effect. Hormones, though, are relatively slow acting because hormones secrete from a gland into the bloodstream and then float around and go to whatever body part that they need to affect. Sometimes that body part is in the brain, and those hormones can get in the receptor sites to have their effect, to do their job. But hormones can go to other parts of the body and have effect as well. Okay? Don't ignore this part. Check it out at the top of the screen here. Hormones, folks, are part of what's called the endocrine system. the endocrine system. Neurotransmitters are part of the central nervous system. Okay, so quick recap. We got the central nervous system, brain and spine. They've got neurons, and neurotransmitters do the work there as chemical messages. Then you got the peripheral nervous system. The peripheral nervous system with the somatic branch and the autonomic branch. We've been all over that. And the peripheral nervous system, like the autonomic branch, takes advantage somewhat of the endocrine system, a completely different system. No neurons, here doing all the job anyway. We've got glands secreting hormones, doing the job of the endocrine system. But folks, one of the things we're going to see here is these three systems, they work together and affect each other. I'll show you that momentarily. First, take a look at these glands. Now, you should have already done some research for an assignment, your brain and body parts. You should know this stuff already, but I wanted you to see the location. Right, the pineal gland is sort of in the center rear of the brain. And the pineal gland, we'll learn more about that later, secretes melatonin, makes us sleepy, makes us tired. Not to be confused with the pituitary gland. The pituitary gland, one thing that it does, it secretes growth hormones, especially throughout puberty. The pituitary gland secretes all kinds of hormones that can affect our growth and our growth of body hair and the changing of our voice and changing of our bodies and the growth of our secondary sex characteristics and like body hair under the arm and all that stuff, of course. But don't confuse these two glands that start with a P. The pineal gland has a lot to do with our sleep-wake cycles, especially making us feel tired. The pineal gland secretes melatonin when we're in the dark. Just, it's reflexive. Right now, if you shut the lights down in your room, your pineal gland is going to start secreting melatonin, even if it's not bedtime. Okay, if you're in that dark room long enough, you'll probably start to feel tired thanks to melatonin. More on that in the future. The pituitary gland, besides growth hormones, folks, the pituitary gland is your master gland. It is the gland of the endocrine system that is in charge of most of the other glands. So the other glands will get messages from the pituitary when it's time for those other glands to do their job. All right? Come back to that in a little while. Notice your thyroid gland. The thyroid is kind of the butterfly-shaped gland in your neck, and the thyroid affects your metabolism. It secretes a hormone called thyroxine. And yeah, when you do that assignment for the brain parts, hopefully you mentioned the name of the hormone and the effect. If not, some of them are pretty easy. The main hormone, I should say, like thyroid secretes thyroxine. The pineal gland secretes melatonin. The pituitary secretes all kinds of hormones. You don't have to memorize all of them. Just try to get the basics down and let me know where you have questions. Metabolism, folks, is your body's using of energy. Metabolism is how your body is burning up calories, using up energy. If you have a very high metabolism, then you're going to burn calories very easily, probably have a lot of energy, not get tired very easily. If you have a low metabolism, you're not using energy very much, maybe very efficiently. If you have a low metabolism, you may have a hypoactive thyroid gland. Your thyroid might be underactive and you're not burning up energy like you're supposed to. You might feel tired and lethargic, just you don't want to do anything. You sit around, you might gain weight easily. Think about why this is important, by the way, in psychology. If for no other reason, we need to make sure if a person seems to be clinically depressed, let's maybe do a blood test along the way and make sure they don't have a thyroid condition that makes them fatigued and undermotivated and seemingly sad and depressed. It might just be a thyroid condition. It's part of the reason we need to know this stuff, in case you were wondering. What else? You can read the rest of the stuff that's on here. We don't need to know the thymus, really. I don't think we really need the parathyroids all that much for the AP exam. Well, we do have the ovaries and testes, of course, the sex glands. They secrete hormones. Ovaries secrete a bunch of estrogen, of course, and the testicles, the testes, secrete testosterone. We know that has an effect on female and male sex characteristics. Testosterone makes body hair grow, makes vocal cords change so that voices tend to be deeper. Testosterone also aids in muscle development, um, and estrogen helps with, changing the body in a more, um, you know, generally considered female way, right? Growth of hips and breasts. If a man has a lot of estrogen in his bloodstream, he will grow fatty tissue in his chest. It will look like he's got breasts. Estrogen has that effect on the physical body. There's some research suggesting that testosterone also affects aggressive behavior. Some research shows that women who are in prison for violent crimes oftentimes have increased testosterone levels in their bloodstream. This does not mean that, you know, violence only comes from testosterone, but psychology, we're finding chemical effects on behavior, and that's just one to mention. All right, we see the adrenal glands that we've learned about on top of the kidneys here. We know what the adrenal glands do as part of sympathetic arousal, pumping out epinephrine, norepinephrine, cortisol, those stress hormones to get the body activated and alert. Those are the glands of the endocrine system. An overview of it. But there's one thing I haven't mentioned here, folks, that is very important, and that is the role of the hypothalamus. Here's where we bring together the central nervous system, because the hypothalamus is a part of the brain, and the endocrine system, the system of glands and hormones. These glands are not part of the central nervous system. They're outside. Adrenal glands on top of the kidneys, the testes and ovaries, are not in the brain or the spine. Now, the pineal and the pituitary glands are in the brain, but since they're glands, they're considered not part of the brain, technically. They're part of the endocrine system. They're glands that secrete hormones. But the hypothalamus is right there. Remember what we mentioned before, folks? The pituitary gland is the master gland. The pituitary gland oftentimes is going to command the other glands by spitting out hormones that go through the blood and affect other glands and make them activate or inhibit to pump out hormones or not. The pituitary is the master gland. Here's what I did not mention. The hypothalamus is the overall master of the endocrine system. So the pituitary is the master gland, but the hypothalamus is the master of even the pituitary. The hypothalamus, think back to what we've learned about the brain. I think of the hypothalamus as kind of the maintenance worker of the body, kind of the janitor of the body, right? The custodian. And by that, I mean that the hypothalamus is regulating the body overall. The hypothalamus, let's take a look. Okay, a couple things I want to do. Stop share and go to my handy dandy PowerPoint presentation where we had a slide on this MRI. Take a look here. Here, as we look at this MRI, we see the medulla, the brain stem. We see the pons here located on the front of the medulla. The medulla leads up to the thalamus. We'll learn more about this in class. But under the thalamus, here's the thalamus here in the center on top of the medulla. And under and sort of in front of the thalamus, we've got this region here called the hypothalamus. Remember, the prefix hypo means under. If a person's hypoactive, they're underactive. I mentioned hypoactive thyroid. That's an underactive thyroid. A hyperactive thyroid would be an overly active thyroid, a person with a very high metabolism. Okay? So anyway, prefix hyper, over, hypo, under. Hey folks, this part of the brain is the hypothalamus, and it's located under The thalamus. See what they did there? You see what they did there? Hypothalamus is under the thalamus. That's pretty nifty. I don't know where this voice is coming from. Anyway, under the hypothalamus, look at this thing. See this like little light colored like stem thingy? That's the pituitary gland. The pituitary is hooked up to the hypothalamus. And there's a reason for that, because the hypothalamus here in the center of the brain is in charge of the pituitary that's in charge of all the other glands. All right? The hypothalamus is the part of the brain in charge of the whole endocrine system. And that's how the hypothalamus regulates the body. It does so by commanding its underlings, the glands. So, for example, when the lights go out in your room, the hypothalamus is going to get the message as your eyes are sending them the information back the optic nerves to the occipital lobe. Look at this. Oh my, it's so great. As the optic nerves are traveling to the occipital lobes to give information about what we're seeing, the hypothalamus is going to pick up the information that, whoa, it's a lot darker in here. Hey, it's darker, hypothalamus says. Pineal gland back here. It's dark. Give us melatonin. Pineal gland goes, okay, boss, here's the melatonin. Goes through the bloodstream, calms the body down, tells the medulla and the pons, slow down the heart, calm us down. We want to go to sleep because it's dark. Humans are naturally nocturnal. All right, the pineal gland just followed orders because the hypothalamus told him or her or it or she or them, whatever. Oh, we need gender glands. That's weird, right? Anyway, the hypothalamus told the pineal gland when it was time to do its job. That's the hypothalamus's job, to regulate what's going on in the body. Now check this out. The hypothalamus is also, since it's under the thalamus, sort of on top of the medulla as well. And that just makes sense. It's right here in the center of the brain, because as information's coming into the brain, the hypothalamus can try to register and make sense of what's going on with the body and see if something needs to be changed, right? As the stomach tells us, hey, we're empty down here, we're hungry, like whatever, the hypothalamus, part of it, will register that, oh, stomach's full, okay, well, let me adjust hormones here and we'll make the body feel hungry. We'll fill that stomach up if it needs to be. Oh, wait, what's that? Hypothalamus registers, no, the stomach's full, we don't need to eat anymore. Oh, okay, let me tell the other glands of the body to adjust hormones, and we'll make ourselves feel full in response to the information that came up to the brain. All right? The hypothalamus is the regulator, the maintenance worker of the overall body, and that maintenance worker's tools are the glands and their hormones throughout the body. All right? One more example of that, folks, is let me see if I can switch to, let's see if this works here. Hopefully we're seeing our endocrine system diagram again. And we know about all these glands. Let me show you, though, a specific axis, a group of body and brain parts that work together. It's called the HPA axis. Let's bring all this together, folks, what we've learned here recently. The HPA axis is a very important team of your brain and body. As you can see, it consists of the H, hypothalamus, P, pituitary, and A, adrenal glands. Now, we know the pituitary gland is not down here in the chest. This is a bad diagram. I just wanted you to see kind of the flow of information that would go here. Whenever we put all this together, whenever the body needs to change, if we need to go into sympathetic arousal, the hypothalamus is going to communicate to the pituitary gland to say, hey, we need excitement here. There's wrestling behind that bush. Let's go. We need alertness. We need excitement. Stimulate the body, pituitary, go. And the pituitary goes, okay, boss, let me talk to my underlings. I'll get the adrenal glands to pump out. Hypothalamus is like, no time for talk. Let's go, man. We need stimulation. This bear might eat us. This is stupid. The brain doesn't talk like that. But anyway, pituitary goes, okay, boss. Hey, adrenal glands, give us epinephrine, norepinephrine, cortisol. We need those stress hormones. And the pituitary hormones travel down in the bloodstream to the adrenal glands, and they take effect, right? The epinephrine, norepinephrine, cortisol go into the bloodstream, work its way up through the heart, up to the hypothalamus, to the brain, and that aids in the sympathetic activation, the fight or flight mode that we go into. Why did the adrenal glands do that? Because their boss told them to. Their boss is the pituitary. And how's the pituitary know to give those orders? Because the pituitary's boss told it to. And that boss is the hypothalamus. HPA. Hypothalamus to the pituitary to the adrenal glands. H to the P to the A to the ISO. A to the is no. Okay, anyway. HPA. That's not the end of the story though. When Philip comes out from behind the bush and we see, oh, you jerk, you scared me. I thought you were a bear who came to gobble me up, whatever. Look, the hypothalamus is the part of the brain that's going to help register. Oh, no danger here. Hey, pituitary, tell the adrenal glands to calm down. We don't need the epinephrine anymore. Cut it out. Hypothalamus tells the pituitary. Pituitary goes, okay, boss. Hey, adrenal glands, stop it with the epinephrine. We don't need it anymore. It's just stupid Philip. Adrenal glands go, okay, boss, and stop secreting epinephrine. Parasympathetic activities take over, and the body calms down. All because the hypothalamus starts this process, and we've got the regulator, hypothalamus from the central nervous system, giving orders to the pituitary gland, part of the endocrine system, which continues that communication to the adrenal glands. And we've got the peripheral nervous system now activated with sympathetic arousal or parasympathetic calming, all because of this HPA axis, this one team that helps bring together all those parts of the body so we stay alive. Thanks, everybody.